Hi guys, welcome back, and we're going to wrap up chapter 12 with more fun with stoichiometry, and we're going to be investigating a couple of problems all revolving around the same chemical reaction where we take our silver nitrate solution and we combine it with solid copper and we get a copper nitrate solution and silver solid. We've done this in lab. Perhaps you remember growing some really pretty silver crystals and looking at them under magnification, and some of you took videos and photos of them as well. Let's say that we start out with 5 grams of each of our reactants. So we are going to have 5 grams of silver nitrate and we are going to have 5 grams of copper. What is our limiting reagent? This is the first problem we're going to work with. And I know we've done these before, but I'm going to talk you through this slowly. Why is it important to identify the limiting reagent? Because the limiting reagent controls how much of the product is made. For instance, if I reworded this equation and I said, here's your reaction, this is how much of each reactant we have, calculate how much silver is made. You wouldn't be able to calculate how much silver was made until we identified which one of these guys was our limiting reactant. So that's where we're going to start. So the first thing we do, since we're in grams, is we're going to convert our substance to moles by dividing by the molar mass. The molar mass of silver nitrate is 169.9 grams. So we have 5 divided by 169.9. And that gives us 0.03 moles of silver nitrate. We'll do the same thing for copper. All we're going to do is convert into moles. The molar mass of copper is 63.5 grams. So we have 5 divided by 63.5, and that is 0.08 moles. We're rounding to just 1 sig fig here. Now, what is important to understand is that these are still my given quantities. Whoops, I wanted that to be a straight line. Sorry about that. These are my given quantities of silver nitrate and copper. All I did was convert to moles. I'm only halfway through the process of identifying the limiting reagent. All right. So this is my next step, will be identifying that limiting reagent, and I'll do that in green. So what we do is we take what we're given in moles. Now what I want to do here is I want to figure out how much copper is needed to react with this much silver nitrate in perfect proportion. So since my balanced chemical equation gives me those perfect proportions, I need 1 mole of copper for 2 moles of silver nitrate. So my problem is 0.03 divided by 2, which is 0.015. And forgive me for not using sig figs here, but 0.015 moles of copper is what I calculate here. Okay, this now is my needed quantity of copper. And so what I'm comparing it to is my given quantity of copper. So what I'm going to do is, let's go to red. I'm going to circle this in red. Here's my needed quantity of copper. Here's my given quantity in copper in red. We have to compare the same substance with the same substance. Okay? We're not comparing this with that. They're not the same substance. They're apples and oranges, copper and silver nitrate. We have to compare copper with copper. I need 0.015 moles of copper. I have 0.08 moles of copper. So I have more copper than I need. Therefore, copper is my excess reagent. And that would tell me then that silver nitrate is my limiting reagent. And really, I'm done there. I've identified the limiting reagent. But really what I can do is I can prove that by calculating how many moles of silver nitrate are needed to react with my given quantity of copper in perfect proportion. So this is a 2-to-1 ratio of silver nitrate to copper. So I'm taking 0.08 times 2, and that is 0.16 moles of silver nitrate. This is my needed quantity. So I'm comparing silver nitrate to silver nitrate. I need 0.16 moles of silver nitrate. I have only 0.03 moles of silver nitrate. I don't have enough. So this clarifies that silver nitrate is my limiting reagent. I don't have enough. And it is the silver nitrate now that it is going to control how much product is made. So let's say I want to find out, well, how much silver can I make from this reaction? How much silver can I make? Well, I'm going to start out with the given quantity of my limiting reagent, 0.03 moles of silver nitrate. I'm going to multiply by the mole ratio of silver to silver nitrate. I have 1 mole of silver for every 2 moles of silver nitrate. And then I'm going to convert to grams. I want to know how many grams of silver. The molar mass of silver was 107.9 grams in 1 mole. So my problem becomes 0.03 divided by 2 times 107.9. Whoops, I'm using this teeny tiny calculator on my cell phone. So my 47-year-old eyes are having trouble here. Times 107.9, and I get 1.62 grams of silver. That's how much I would make, given these 2 reactants and identifying the limiting reagent. Okay, so we're back, and we're going to work with the same reaction we did before, where we have our silver nitrate solution, we add some copper, and we make a copper 2 nitrate solution, and a pretty silver solid. This time, I want to make 10 grams of silver. I want to make 10 grams of pretty silver crystals so I can take home and show mom and dad. How much silver nitrate do I need? All right, so what we do is we start out with our given quantity. 10 grams of silver. I'm going to convert to moles. The molar mass of silver is 169.9 grams. And I'm going to multiply by the mole ratio of silver nitrate to silver, which is a 2-to-1 ratio. And then I will convert to grams of silver nitrate. And I think I made a boo-boo. Yeah, let's go back here. I have, if you find my error, does anyone find my error? The molar mass of silver is not 169.9. The molar mass of silver is 107.9. Okay, it is the molar mass of silver nitrate. That's 169.9 grams. And so now my problem is set up. So I have 10 grams. I divide by 107.9, multiply by 2, and multiply by 169.9. How much silver nitrate do I need? 31.5 grams of silver nitrate is needed. Okay? How much copper would I need? we'd set up the problem the same way. 10 grams of silver, convert to moles. This time, I'm going to multiply by the molar mass of copper to silver. This is a 1-to-1 ratio. 1 mole of copper for 1 mole of silver. And then I need to find grams of copper, so I'll multiply by the molar mass of copper, which is 63.5 grams in 1 mole. So my problem becomes 10 divided by 107.9 times 63.5. And I get 5.89 grams of copper. So these would be the quantities of both reactants needed in perfect proportion to each other. Okay? If I change these proportions, so if I increase the amount of copper here, copper then would become my excess reagent, and silver would be my limiting reagent. Okay? If I increase my amount of silver, silver would be my excess reagent, and copper would be my limiting reagent. So if I just change the amounts of just one of these reactants while keeping the other the same, we will have a limiting reagent and an excess reagent. However, we will still only make 10 grams of silver. That's important to remember. All right? The limiting reagent controls the amount of product that's being made.